Hello everyone. Today I'll be talking about refraction, a basic principle in the study of light. Have you ever wondered why a straw appears distorted in a glass of water? Well, the answer is not far from what you would think. The water literally bends the light, causing it to appear abnormally. This process is called refraction, which is the bending of light as it passes from one medium to another. But why does this happen? Light changes speed when passing from one medium to another, causing the light to bend. And now that we know the general idea of refraction, let's take a look at an example to get a closer look at what refraction really does. Here, we have a flashlight in the top left corner shining light at an angle towards some glass, which is represented here by the horizontal line and everything below it. To make things easier, let's focus on one individual ray of light, as shown as a yellow arrow. Let's define some key terms to know when studying refraction. The point where the ray first contacts a glass is called the point of incidence. From the point of incidence, let's draw an imaginary line perpendicular to the surface of the glass. This is called the normal line, and we will refer back to it numerous times later on. As stated before, refraction causes light to bend, so we'll draw another yellow arrow indicating the direction of the ray of light after it penetrates the glass. The original ray is called the incident ray, and the new ray that is refracted is called the refracted ray. From the incident ray to the normal line lies an angle called the angle of incidence. Likewise, the ray created by the refracted ray and the normal line is called the angle of refraction. Now this is cool and all, but how do we actually solve for the angle of incidence and the angle of refraction? Well, in 1621, Willibrord Snell developed this equation named Snell's law. It helps us calculate the angles we mentioned earlier. The equation is as follows. N sub 1 times sine of theta 1 equals 2 n sub 2 times sine of theta 2. Now what do all these variables really represent? Let's take a look at n sub 1 and n sub 2 first. In optics, n is a variable that describes a medium's index of refraction. This value determines a medium's ability to change the speed of light as light passes through the medium. This also sometimes is referred to as a medium's optical density, which is different from physical density. Again, optical density just tells us how a medium can regulate the speed of light. Theta 1 is our angle of incidence, and theta 2 is our angle of refraction. In our example, we can assume that the light coming right out of the flashlight is passing through the air, which has an index of refraction of 1, then passing through glass, with an index of refraction of 1.5. One thing to note is that when light passes from a less optically dense medium, which has a smaller n value, like air, to a more optically dense medium, like glass, the angle of refraction is smaller than the angle of incidence. Likewise, if we were to reverse the experiment and have the light first shine through glass, the more optically dense medium, into air, we can see that the angle of refraction is a lot larger than the angle of incidence. Hopefully, you learned a lot about refraction in this video, and I hope you're able to answer some of the questions on the screen. Refraction is a fundamental principle in optics that has many practical applications in our daily lives, from the glasses we wear, to the cameras we use, and even the way we see rainbows. Understanding how light bends when it passes through different materials helps us appreciate the science behind these everyday phenomena. If you enjoyed this video, don't forget to like, comment, and subscribe for more science content. Thanks for watching.